In the last class, we discussed what's the general plan for analyzing the time complexity of non-recursive algorithms, that is also known as iterative algorithms. What is the first thing that we need to do? We need to decide on parameter indicating input size. If it is a sorting problem, what is the parameter that indicates input size? If it is a sorting problem, the parameter indicating input size is number of elements given to us to sort. Okay, so that is n. And what is the algorithm's most important operation? That is basic operation we need to identify. Next, the most importantly, we need to determine whether number of times basic operation is repeated. It depends only on input size, but also or actual values in the input also. That is actual instance also. If it not only depends on input size, but also actual values in the input, then the procedure is different. Okay, different, that we will see. Next, after that, we need to, if T of n is total number of times that basic operation is performed when n is input sign, then we need to give an expression for T of n. After that, we need to simplify and find out its order of growth. Or after getting order of growth, we can represent it using some asymptotic notation. Some asymptotic notation. What is some asymptotic notation here? Represent number of times basic operation is performed. Basic operation is performed using some asymptotic notation. That's all. This is the procedure or steps that we follow in order to analyze non-recursive algorithms. So in case of this algorithm which finds sum of all elements in the array, what is input size? What is the parameter that indicates input size?
Number of
what is the parameter that indicates input size?
Number of elements in an array.
Input size is n. Number of elements, that is n. What is basic operation? What is basic operation? This operation we consider as basic operation, that is addition. So now here, if T of n be the number of times basic operation is performed, then T of n, it depends only on n or actual values in the input also. It depends only on n. It depends only on n. So once it depends only on n, then we can find what is T of n. What is T of n here? S equal to S plus A of I operation is performed for each value of I from 1 to n. Hence, we can write it as sigma I equal to 1 to n 1, which is same as n minus 1 plus 1. So that is n. Next, what is order of growth of T of n? Order of growth of T of n is n. This is T, its order of growth is n. What next? Then represent T of n using some asymptotic notation. So T of n can be represented as theta of n. Is this correct? Yes. So that's what we discussed in the previous class. Is there any doubt in this? Okay. So you please, all of you, see this. Whatever we discussed, no, same thing is here. Okay. Next. Okay. So this algorithm, what does this algorithm do? What does it do? If we are given two matrices, say A, which is n by n, and B, which is also n by n matrix, it finds matrix C equals to C equals to what? C equals to what? A plus B. A plus B. So in order to find this, what is that we do? If it is something like this, corresponding elements we add in the both matrices, no? This element with this element we add. This element with this element. We take sum here. Like this we keep adding. We keep adding. So is there any doubt in this algorithm whether it correctly calculates sum of two square matrices? Whether it correctly calculates sum of two square matrices or not?
Yes, sir.
Yes, okay. So our main intention here is to calculate the running time. So now tell me, what is parameter indicating input size? Parameter indicating input size. What is input size here?
N square.
What is input size here?
N square.
N.
If we take n, that is sufficient. No, if we take n, that is sufficient. We know that there are n square elements. Now, what is most important operation here? That is basic operation.
Addition of two elements.
This is this orange color. This is addition, no?
Yes, sir.
This is our most important operation. Addition operation. Addition. So now if n equal to 2, n equal to 2, for example, our matrix is 2, 3, 4, 5. This is A. B is 1, 2, 5, 7. How many additions are performed in this case?
4.
What is T of 2? How many additions are performed?
4, sir.
4. If n equal to 3, that means A is 3 by 3
9.
matrix. B is 3 by 3 matrix. How many additions are performed?
9.
9. So this 4 can be written as 2 square.
2 square.
This can be written as 3
3
square. In general, if there are n elements, how many times this operation is performed? How many times
N
this
square
operation
times.
is performed?
N
N square times. Now you tell me, if T of n is, let T of n be the basic operation count. Basic operation count. Now you tell me T of n, it depends only on n or actual values in the input also.
Depends on n only.
That means instead of A if we give as 1, 1, 2, 3, B is 3, 5, 1, 4. Whether the number of operations here also input size is 2. Here number of additions performed, whether how much? How many additions 4 are performed in this case also?
4.
2 square, that is 4. That means for the same input, is there any change in number of operations performed?
No, sir.
No. That means T of n, it depends only on n. Only on n. Next, what next? What is the next thing that we need to calculate? We need to give an expression, a summation expression for T of n. Now tell me, how many times T of n, okay, no, this operation is performed. Clearly, this is inside this second step, no, that is this for loop. This operation is inside this for loop. That means for each value of j, when j equal to 1, it is performed one time. J
Yes,
equal to 2 also it is performed one time. J equal to 3 also it is performed one time. On this one, j equal to n also it is performed one time. Is that correct?
Yes, sir.
For each value of j from 1 to n, it is performed one time.
Yes, sir.
But this entire j equal to 1 to n is performed for each value of I. When I equal to 1, this entire operation is performed or not? Similarly, when I equal to 2, j equal to 1 is performed, 2 is performed, 3 and this one n is performed.
Again 1 and 2.
When I equal to 3, When I equal to 3, j equal to 1 to n. No, j equal to 1, 2, 3, and so on n. This is performed. And so on. When I equal to n, again j equal to 1, j equal to 2, and so on, j equal to n is performed. That means this entire operation is performed for each value of I from 1 to
10 times.
1 to n. So we can say that this entire operation is performed for each value of I from 1 to n. Is that okay? Is that okay? Now, what is that we need to do? We need to simplify this. What is this value? What is this part? J equal to 1 to n 1. What is this value? What is the value of this? J equal to 1 to n 1. What is sigma j equal to 1 to n 1?
N, sir.
This is of the form lower bound to upper bound 1. So it is upper bound minus lower bound plus 1, which is same as n. That's what no in the previous example also same thing we had no. So in place of this entire thing we can replace n. Now what is this value? What is this value? When I equal to 1, this n I can write it as n is independent of I or not. N is it independent of I or not? Is it independent of I or not? So n we can take it outside. I can write it as sigma n equal to 1 to n 1. Is that correct? Because n is independent of I, we can take it outside. So that becomes sigma I equal to 1 to n 1. Is that correct? Is that correct?
Yes, sir.
So now you tell me again, what is this value? N is outside. What is this value?
N.
What is this value?
N.
It is n. So finally it is n square. It is n square. Now tell me what is order of growth of T of n? What is order of growth of T of n?
N square.
Order of growth T of n is n square. N square. Okay. Now sixth step. What is last step? What is last step? What is last step?
Asymptotic notation.
Now we need to represent T of n using some asymptotic notation. Say T of n, can we write it as theta of n square?
Yes, sir.
Is that correct or not?
Correct, sir.
Correct. Instead of this, is it possible to write T of n as big O of n square?
That is also correct.
Okay. If we want, is it possible to write it as big omega of n square?
Yeah, that is also correct.
Okay. Now you give me one answer where in terms of big O, where it is also correct. One answer for T of n, and your answer should be in terms of big O, but it should be correct.
Big O of n to power 2.1.
N power 2.1. This is also correct.
Yes.
But out of these two answers, which is our favorite answer?
Big O of n square.
Because big O notation gives upper bound. Upper bound should be as small as possible always. Then it becomes very close to actual value of T of n, actual order of growth of T of n. Okay, that's why this is correct, but it is not our preferred answer. So we prefer only this. Nobody writes like this. Okay. Similarly, can you give an answer in terms of big omega? T of n is big omega of 1. Is that correct or not?
Yes, correct, sir.
Correct. But is that answer is better or the big omega of n square is better?
Big omega n square is better.
Why? Because big omega gives lower bound. Lower bound should be always as high as possible. N square is more than 1. No. That's why this is our favorite answer. Is that okay? Like this, T of n we can represent using different notations. Can you give me an answer for T of n in terms of little o?
Yeah, n power 2.1.
N power 2.1. Is this correct?
Yes.
If I write n power 2.01.
That's also correct.
Is also correct. This is also. Can you give an answer for this in terms of little omega? Little omega of n square. Is this correct?
No,
T
sir.
of n is little omega of n square. Is that correct?
No, sir.
No, this is false. But T of n
N
is
power
representative of
1.9.
n power 1.99. Is
Yes.
that correct?
Yes, sir.
Yes. So once we know order of growth, then whichever notation we want, we can represent using that notation. So
Yes,
some
sir.
people may write theta of n square, because favorite answers are these three. Some people may write theta of n square, some people may write big omega of n square, some may write big O of n square. If you exactly know that its order of growth is n square, out of these three, which notation is best? I know that exactly its order of growth is n square. Out of these three, which notation is best?
1.99.
No. My question is,
Big
out
omega.
of this n square, big O of n square, big omega of n square, theta of n square, which is best?
Theta, sir. Theta
Theta
notation.
of n square is best.
Theta.
That means
Yes.
again you can correlate with that example. If you know that exact cost of the book is 1550 rupees, 1500,
Yes, sir.
one student may say it is not more than 1600, or sorry, one student may say it is not more than 1550. One student may say it is not more than 1550, not less than 1550. Another one may say exactly 1550. All are correct. Then 1550 becomes our favorite answer, no? That is the
Yeah,
reason
yes, sir.
we prefer this. If you write big O of n square, that is also correct. But is that okay? Knowingly, why should I give confusing type of answer? That is the meaning. Shall we go to next? Now what happens in this algorithm? Okay, without even knowing this, what does this algorithm do? You please tell me what is input size here? What is input size?
N. Number of elements.
What does this algorithm do? What does this algorithm do?
Gives you the minimum element in an array.
No.
Sorry, minimum difference. Huh?
So these are some four elements. This is say 10, 8, 20, 6, something like this. What is the output?
Minimum
If
difference.
input is this, what is the output this gives? What is the output this algorithm gives?
2.
Array name is 8.
It returns 2, sir.
Okay. What is the answer that it gives? 2.
Yes, sir. 2.
Output is 2. Is this correct? Is that correct? Yes,
Yes,
this is correct. What does it do is, between every pair of elements, no, it finds distance. What is distance between 10 and 8?
2.
10 minus
2,
8.
sir.
10 minus 8, that is 2. What is distance between 10 and 20?
10.
It is 10 minus modulus 20, it is 10. Similarly, like that, all possible, every distinct pair of elements, same elements we are not calculating. That's why here I not equal j condition. Okay. Otherwise, what happens? Always it will be answer 0, no? Are you getting?
Yes, sir.
Otherwise, that element, if I subtract from that, always we get its answer as 0, no? That's
Yes,
why
yes.
we are taking different elements. That's why this condition I should be different from j. I should be different from j. This is absolute difference. So finally, answer in this case is 2. Now, what is input size here? What is input size here? What is input size here?
N.
How many elements are given to us? Okay, so we can take it as n. Next. What is basic operation here? Our most important operation. What is most important operation in our algorithm? What is most important operation in this algorithm?
Subtractions and comparison.
So that is in step 4 or step 5, sir?
Suppose, see, either we consider
In the
4,
fourth step.
5, yeah.
In the
Is it
Both
in
fourth
are
step.
having,
step 4 or step 5?
Step
step
4.
4, step 4.
Step 4. Step 4. But in step 4, 2 operations are there. Correct, no?
Yeah, yeah.
Yes, sir.
So which operation we consider?
Subtraction.
Okay, let us consider this. Okay, I will explain with this also answer. Okay, first let us consider this. What is this? Comparison operation. Subtraction comparison is also happening, no? Multiple operations we are performing. Here either you consider it as subtraction or comparison. Comparison or subtraction. Okay, whichever it may, okay, no, both are same in this case, because next, let to T of n be the every time what is T of n? What is T of n?
N square.
No. Basic operation count.
Oh, so
Basic operation count when n is input size. Input size. Is that okay? Okay. Now, what is the next thing that we need to decide? Whether number of times this operation is performed. Okay, let us say, okay, I'm talking about comparison operation. Number of times this comparison operation is performed, it depends only on number of elements in the array or what are the actual elements in the array also. That's what we need to decide. So in this case, what is the value of n? N equals 4. N equals 4. N equals 4. Now you take any other array with n equals 4. This may be 10, this may be 5, this may be 2, this may be minus 3. N equals 4 here also. Okay. Now how many times, what is T of 4 value here and what is T of 4 value here? What is T of 4 value in the first one and what is T of 4 value in second one also? In this, when I equal to 1, when I equals to 1, what are the values j can take? J equals
1 to 4.
2 to 4. J equal to 1, it doesn't take, no?
But comparison will perform, no?
No, but see, okay, one more important point. If condition, when does that if condition become true? If we have two conditions, if
First
condition
one is
1
true. Yeah.
and condition 2.
Hmm.
If condition 1 is false, is it necessary to evaluate condition 2?
No.
No. Is that correct? Okay.
Yeah, correct.
Okay. Okay, we will come back to this and I only last question. Okay. When I equal to 1, j can take value from 1 to 4. 1 to 4. But how many times, whether j equals to 1, whether that operation is performed? This comparison is performed or not? It is not performed.
Not performed, yeah.
Why? Because I not equal j condition fails, no?
Yes, yes.
When I equal to 1, j also equals to 1. So that is not performed. J equal to 2, comparison is performed. J equal to 3 also comparison is performed. J equal to 4 also comparison is performed. That means when I equal to 1, how many times comparison operation is performed?
3 times.
3 times. Now look at a case where I equal to 2. When I equal to 2.
It also perform 3 times.
What are the values? J equal to 1, whether it is performed or not?
Yes.
Comparison, it is performed. J equal to 2,
No.
not performed. J equal to 3, it is performed. j equal 4, it is performed. J equal 4, it is performed. That means when I equal to 2, how many times it is performed? When I equal to 2, how many times this comparison operation is performed? Here also 3 times.
3 times.
When j equal to 3, when j equal to 3,
It also perform 3 times.
3 times. When j equal to 4,
3 times.
3 times. So what is that 3? What is that 3? Is it possible to write it as n minus 1, where n
Yes.
is 1, 4? Here
Yes,
also
yes.
it is n minus 1. That means for each value of I, n minus 1 times this operation is performed, no?
Yes,
For
yes,
each
right. Yeah.
value of I, this comparison operation is performed n minus 1 times.
Yes.
Okay. But okay. Now, if n is 4 and the elements are 10, 8, 20, 60. Next here n is 4, elements are 10, 5, 2, minus 3. That means both are different instances or not? Different
Yes.
instances or not? Different instances. Now, is there any difference in number of times that comparison operation is performed in both the cases?
No.
No. In general, instead of this, any other instance whose size is 4, if you take, whether is there any difference between number of operations comparisons performed in the cases?
No.
Any instance of size 4, if we take, is there any difference between number of or times that comparison operation is performed?
No.
Correct, no. Irrespective of what are the elements here, it doesn't matter, no. Whatever element is there, you take as absolute difference, that's all. But operations we need to perform, no? Operations we need to perform. So that means, now you tell me what is T of 4? When I equal to 1, how many times it is performed? 3 times. When I equal to 2, how many times? It is 3 times. When I equal to 3, 3 times. I equal to 4, 3 times. Total, how many times it is performed? 12 times, no? Here, what is T of 4? Here also, when I equal to 1, how many times it is performed? Three times. I equal to 2 also 3 times. I equal 3 also 3 times. I equal 4 also 3 times. That means it is also 12. That means here, for the input size is same. From this, it is clear that number of times our basic operation is performed is also same. It is same. That means what? Our T of n value, it depends only on input size n. It doesn't depend on what are the actual values in the input. That means it doesn't depend on input instance. Okay, now
Yes.
it doesn't depend on input instance. Okay. Okay. Next. Okay. It now clear that T of n depends. T of
On number of
depends only on
number of
depends
elements.
only on n. Okay. What is next? Fourth step. What is next? What next? What next?
Operation count.
Operation count. What is T of n value? What is T of n value? Now, for each value of j, whether this operation is performed or not, for each value of j, 1 to n, whether this operation is performed or not, comparison operation is performed or not.
No, sir. -1 time. No.
That is only when I equal to j, it is not performed. When in all other cases, it is performed. And this entire operation is performed for each value of I. Each value of I. So I equal to 1 to n, I not equal to j. It is one time. Is that okay? Now, what is this value? What is this value?
n-1.
That's what we calculated. No, only when I equal j means one value comes less. Overall, this value is n. Only one place it is I equal to j. I equal to j. I not equal j is how many times?
n-1 time.
N minus 1 time. It is n minus 1. Now tell me what is this value? When I equal to 1, what is n minus 1? 1 minus 1. When I equal to 2, this is I equal to 1 case. I equal to 2, 2 minus 1.
No, sir, every time it would be n minus 1, no?
Okay, this is not I know.
Yeah. So every time I n minus 1.
Okay. Thank you, sir. Okay.
This is a constant, sir.
1 second. N minus 1 is constant. It is independent of I. So we can take it outside now. Is that okay? We can write like this.
That is fine. Yeah, perfectly fine.
Is that correct?
Yeah, correct.
N minus 1 is independent of I. Sorry. N minus 1 is independent of I. So we can bring it outside. So it is like this. Now tell me what is this value?
N.
So final value is this.
N into n minus 1.
So that is nothing but n square minus n. So therefore T of n is n square minus n. Now tell me what is the order of growth of T of n?
N square.
What is order of growth of T of n?
N square.
It is n square. Is there any doubt? We drop lower order terms as well as constant coefficient. So minus n will go here, no constant, so n square is n square. Now you represent it using some asymptotic notation. T of n. Now T of n, can we write it as theta of n square? Is that correct or not?
Yeah, correct, sir.
Correct. T of n is big O of n square.
That's also correct.
This is also correct. T of n is big omega of n square.
Correct.
That is also correct. Okay. There are different ways of representing its running time. Is the procedure clear?
Yes, sir.
Okay. So we follow this sequence of steps.
Sir, can we take fifth step as a basic operation?
Okay. I'll come to that. Okay. Now fourth step, I not equal to j is there. Now, okay, brother, I'll come to that, brother. First, let me explain this. Then I'll ask the question. Okay. Now, if my basic operation, instead of comparison or subtraction, if I take this as my basic operation. If this is our basic operation. Now you tell me what is T of n value. If basic operation, instead of this, if I take this, input size, is there any change? No. Basic operation is comparison, but different comparison. Okay. Comparison. T of n, the number of times comparison operation is performed, I not equal j. It depends only on input size or actual values in the input also. Actual values in the input also.
No, it depends on instance size only.
Depends only on n. Okay, now what is T of n? What is, in this case, what is T of n?
N square.
What is T of n? I not equal j condition. It is checked when j equal to 1 or not.
Yes.
J equal to 2 or not, not, whether it is checked. Yes. J equal 3, it is checked. J equal 4, it is checked. J equal to n also, it is checked. For each value of j, how many times this condition is checked?
N times.
For each value of j, it is checked n times. So this we can write it as j equal to 1 to n. One time it is checked for each value of j. But this operation is performed for each value of I from 1 to n. So this entire operation is performed for each value of I from 1 to n. I equal to 1 to n. This already we know that it is n square. Is there any difference? Order of growth is, here also order of growth is
N square.
T of n is n square. Now, as he asked, so we can represent T of n as usual using theta as theta of n square. Okay. Now, instead of this, if we consider this operation, whether you can say it as assignment operation or difference operation, that is subtraction operation. Let us consider that as basic operation. So our basic operation is okay, operation is say difference operation. In that case, what is input size here also? What is input size? Number of elements given to us, no? Number of elements in the array. Now,
So we are discussing step 5, right?
no, here this one we are going to consider as basic operation. First we
Okay,
have
step-
considered
step
this
5, yes.
operation as our basic operation. Now we are checking what is the running time, what is operation count. Okay. Okay, in this case, what is input size? If I consider this operation as basic operation,
N.
whether input size changes depending on which operation you consider as basic operation. First of all, you please answer this question. Whether input size changes depending on which operation we consider as basic operation. Whichever operation you consider as basic operation, input size remains same, no? Input
Yes.
envelope, that is same, so no change. Next, what is third step? T of n is number of times this a of I minus a of j operation is performed. Whether number of times this operation is performed, it depends only on input size or actual values in the input. Actual values in the input.
It also depends on actual value on inputs.
No, it depend. That means if n equal 4, number of times it is performed, T of 4, is it different for different instances of size 4?
No, sir.
Sir,
It will be
if we are discussing, step number 5, it will performed only if the step number 4 condition is true. So of course it depends on value also.
No. See, we are only counting, we are not bothered about what is the result of AI minus AJ. What is the operation that we are performing? That is only our concern, no?
But it's an operation in step number 5, right?
Operation in step number 5.
Yeah, the
Correct.
step number 5 will only execute if the condition given in the step number 4 is true.
Correct.
Yeah, so here if there is a matter value also, no?
No, what is these values are only indices, no? They are independent of actual values in the input, no?
So, sir, if difference is not less than the earlier minimum difference, then how it will execute the body of if block?
So, okay, what you are saying is this d minimum, this condition is repeated only these two, when these two conditions are true. When these
Yes.
two conditions are true.
Yes.
Okay. So that means from this it is clear that if this condition is false, whether this operation is performed or not,
No, if it is false, it will not perform, sir.
it will not perform. That means number of times this operation is performed is definitely not more than number of times this operation is performed. Operation given in step 4 is performed.
Yeah, I
Is it
agree.
clear? Okay.
Yeah, I agree.
Now one more important step, as you pointed out, is it T of 4, is it different for different instances? That is the question we are trying to answer. And now the answer is yes or no? Answer is yes or no.
Yes. It is different from different instance size. Different instance.
It is actually different. For example, if n equal to okay, four values, if you take 10, 20, 30, 40, 10, 20, 30, 40. Next instance is 1, 2, 30, 40. Is that okay?
Yeah, right.
Is that okay? In both cases, n equal to 4.
Yes.
How many times this operation is performed in first case? How many times this operation is performed in first case?
12 times.
How many times, brother? Okay, let us put it as 21. Okay, let us put it as 21. Okay, how many times this one? First we'll compare 10 and 20. What is the difference?
10.
10. Next we compare 10 and 30. Correct, no?
Difference 20.
Difference is 20.
So will
20
not
is
execute. Yeah.
more than 10. So
Yeah.
this step is not performed.
Yes.
Step 10 and 40 we compare. What is difference? 30. 30 is more than already whatever difference we got it 10. So that means here when I equal to 1, how many times that operation is performed?
One time only.
Only one time. When I equal to 2, when I equal to 2, 20 and 30 they compare. It compares 20 and 30. What is difference?
So first 20 and 10.
No. Oh, okay, here, okay. Sorry, this is I equal to 2 also. We are starting from here, no? We
Yeah,
are starting from here.
Hmm.
Okay. So in that it is 10.
Yeah. So will not execute because it is not lesser. It's equal. So sir, I equal to 2, it will not execute for any value of j. Hello? 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 Hello?
I think Sar has network issue.
Yes, I also experienced the same.
Huh.
Sorry, this system no got has some problem and automatically it's shut off. Hello.
Okay, sir. It happens sometimes in online
I
sessions.
don't know. It says it ran into some problem and automatically it is restarting, something like that. It displayed.
Okay, okay. That's fine, sir. But sir, all the content that you have discussed is
I
gone,
think
no?
it's not.
There was a message when you opened it, no? Do you want to recover?
I hope there that actual write up was not there.
Yeah, yeah, yeah.
Recording is in progress. So, sorry. Okay. The let us our input size is n. It is n. So what's a basic operation we are considering here? We are talking about this operation. Basic operation is
Comparison and subtraction.
no, difference operation, no?
Subtraction.
Subtraction operation, we can call it. So subtraction operation. Now we were actually discussing this. Let T of n be the basic operation count. Okay, no? Basic operation count. Now T of n, it depends only on n, depends only on n or actual values in the input also. Values in the input. That is instance. Input instance. For example, that if you know, we can take n equals say 4 values, 5, 10, 20, 30, n equals to 4, 1, 2, 4, 20, something like this. Okay. Now, definitely it depends on input size n. That is fine. Now, question is whether it depends on actual values in the input also. Okay. T of 4, what is value of T of 4 here and what is value of T of 4 here? What is T of 4 in first case? In first case, this is say case 1, this is case 2. What is T of 4 in first case? Case 1, first 50 and 10, their difference is calculated now. So what is D minimum that we get? D minimum is 5, correct? Next, 5 and 20 it calculates. 5 and 20 it calculates. So what is the value that we get? What is the value we get? 15. Then it checks whether 15 is less than D minimum. 15 is less than D minimum. Is it true?
No.
No, it's not true. So it is false. So that means whether this operation is performed or not, no. So next it goes to next element, 5 and 30. What is difference? 25. 25 is less than D minimum. No, no. Okay. So that means here only when I equals to 1, this operation was performed how many times? Total, here yes, here no. So total how many times?
One time.
One time, only one time. Next, when I equal to 2, when I equal to 2 means again it compares first one with First one with
5,
first
10,
one
5.
10. Correct now?
Yeah.
So 10, it compares it 10 and 5. 10 and 5. Is that correct? 10 and
Yes.
5. So what is the value we get? We get 5. Okay, first I, first J, next no. Okay, let us write it as 5 and 10 only. Compares 5 and 10. Difference is again 5.
So in the first case, difference would be -5.
Uh,
In second case, difference would be +5.
no, but absolute difference only we are taking both places.
Okay. So absolute. Okay.
Absolute difference.
Yeah,
5
so
and 10,
for-
it is 5.
Yeah.
5, next it compares whether 5 is less than D minimum. Is that correct?
No.
This is false. Next it compares A of I equal to 2. No, I equal to 2 means what is the value? This is 10 and 5 only, correct? No, I equal to 2 is 10.
10 and 20
This is
now.
why.
10,
Next
20 and 10, 30.
10 and
20.
20 it compares. 10 and 20 compares. What is the difference? 10. 10 is less than D minimum. Is this correct? No. Next
10, 30.
A of I is A of 2. A of 2 is how much? 10. 10 minus A of 4. A of 4 is 30. What is the value?
20.
Is that okay?
Yes, sir. It's fine.
Okay. So 20 less than D minimum. Here also condition failed. So that means here how many times it is performed? 0 times.
0 times.
Next, when I equal to 3, similarly you can check now how many times it is performed.
It is also 0 times, sir.
Here also, okay, let me write elements. First it compares 20 and 5. Next to 20 and 10.
10.
Next to 20 and 30. Here also 0 times. When I equal to 4, it compares
30 and 5, 30 and 10, 30 and 20.
30 and 5, 30 and 10, 30 and 20. Is the screen visible?
Yes, sir, visible, but whatever you wrote, it's gone, I think.
I think now it's okay. Something, okay. 30 and 5, 30 and what is next? 30 and 30 and
20.
this is I equal to 4 value. This is J equal to 1. J equal to 1. This is J equal to 2 value. This is J equal to 3 value. What is J equal to 3? It
20,
is
20.
20. All cases it is not performed. No. So here also it is 0. Total how many times this operation is performed? Total how many times this operation is performed?
Only once. One.
Only one time. Only one time. Okay. Second instance, let us take it as say something like this. 10 to 420. 10 to 420. Here first, when I equal to 1, second instance I am writing values. When I equals to 1. So what are the J values? J equals to 1. When J equal to 1, it is not true. J equal to 2. I equal to 1, J equal to 2 means what are the values? 10 and 20. 10 and
2.
2. Second case 2 I am talking about. 10 and 2 are compared. What is difference?
8.
8. So D minimum is
8.
Initially it is 8. One time it is compared. Next to I equal to 1, J equal to 3. That means what are the elements that are compared? 10 and
4.
10 and 4, third place, 4 is there, 10 and 4. 10 and 4, what is the minimum value?
Now it is 6.
Now it is 6. Now it compares 6 with the D minimum. Is it true or not? It is
Yeah, it's true.
That's why D minimum is updated. D minimum becomes 6. Is that correct?
Yes.
Okay, next J equals 4. J equals to 4. What are the values? I equal to 1 only. No, that means 10 and 20 they are compared. 10 and 20. What is the answer we get? 10. Is 10 less than 6? That is D minimum? No. So that means how many times this operation is performed? How many times this operation is performed?
2 times.
Here it is 2, no?
Yeah, 2 times.
I think we need not even do further. Why? Because in this entire instance, only one time T of 4 is 1. Here it is greater than 1, no? Or we can say that it is not equal to 1. That means what? Input size is 4 only, but value, number of times that operation is performed, it is varying, no?
Yes, yes.
So then what is that we need to do? Earlier, whatever examples we considered, there was no such problem. But here, we are not able to calculate, no, exactly. We are not able to calculate exactly. Then what is that we need to do? What is that? See, when we are not able to say exactly how many times that particular operation is performed, or after writing an exam, if you are not able to say exactly how many marks you get in that subject, okay, we can at least say, no, I will get at least this many marks, at most this many marks. Maybe probably I might get something like on average I am expecting this. Okay, depending on the type of correction, something like that, we can say no. So similarly here also, what is that we can say is we can calculate what is the minimum number of times this operation is performed when n is input size. When n is input size, what is minimum number of times this operation is performed? Why? Because for each instance, this value is different. Each instance, number of times it is performed, no, that is different. So we can even calculate maximum number of times this operation is performed. Is that correct? Is that correct? Is that correct? Minimum number of times that operation is performed and maximum number of times that operation is performed. Is that okay?
Yeah.
Okay. But so always what is that we actually calculate in order to find the running time of an algorithm?
Maximum.
That is, we concentrate on those operations whose counts order of growth determines order of growth of entire algorithm, no? Order of growth of entire algorithm. But now we know that number of times, it is clear that number of times AI minus AJ is performed is operation performed is less than or equal to number of times AI minus AJ less than D minimum operation is performed. If we clearly know that this operation is performed, okay, no more number of times, then we do not consider this operation as more basic operation, no? This operation as basic operation. Is that correct? Is that correct?
Sorry, sir.
See,
Yes, sir.
in this algorithm, we know that number of times operation given in step 5 is performed is less than or equal to number of times operation given in step 4 is performed.
Right.
So that means what? That means we have some operation which performs more number of times. Then that operation only we consider as most important operation, no? operation which contributes more to the total running time of algorithm?
Yes.
Its contribution is more than this contribution, no?
Yes. Yes.
Its contribution towards running time is more. Its contribution towards running time is less. So now which operation we should consider as most important operation? Which operation? Operation given in step 4 or 5?
Step 4.
Step 4, sir.
Step 4. Is that okay? Is that clear, brother?
That's clear.
Okay. If you have any doubt, you please ask me. Otherwise, move to next. Okay. Oh, that too we have not completed. What is running time of this algorithm? Finally, what is running time of this algorithm?
Order of
N square, sir.
This is theta of n square. I request all the participants to keep your microphones mute. Okay.
ఎక్కడ స్క్రీన్ దగ్గరేనా
Vijayalakshmi madam, please mute madam.
Is that okay? Okay. Okay, next we move on to next problem. The problem is searching problem. So what is definition of searching problem? What is given as input and what is given as output? What is given as input and what is given as output? So we are given some number, a set of elements or list of elements or an array of elements we are given as input. In addition to that, we are also given another element that we call it as a key. That is our input. What is that we need to find? What is that we need to find in case of searching problem? We need to determine whether key is present in the given list or set or array of elements or not. Array of elements or not. And possibly we output yes if that is present, that key is present in given list of elements. Otherwise, we display say no. Okay, display say no. Is the problem definition clear? What is searching problem? Now, what are instances of this searching problem? What is input size in case of searching problem?
N, sir.
Yeah, because similar to our problem, no sorting problem, here also we have n. There is some problem here also, it is n. This is one instance, 20, 30, 35. What is n value here? N equals to 4. Here input instance n equal to 5, like this. These are different instances. Now, question is how to solve this problem? There is some simple algorithm to solve this problem. What is the name of that algorithm?
Linear search.
Linear search is an algorithm to solve searching problem. Linear search is algorithm. Okay, so how does it work? Say a given elements if you store in an array, how does it work?
It takes one element from the list and searches if it is there or not.
Okay, if all indices, if I consider it as 1, 2, 3, 4, name of the array is A. So some key is given. First, it compares key with, for example, elements. We can take it at 2, 10, 2, 30, 25. Key equal to say 30. So what does it do? First, we compare A of 1 with key. If not equal,
Continue to compare with second.
That means we keep comparing elements from left to right. A of 2 with the key. It is not true. Then we'll compare A of 3 with the key. It is true. Yes, we stop and we say that element is present. If we want, we can even return, yes, we can return that position also. Position is 3. Okay, the position is 3. Element is present at position 3. Is that okay? So now this is it whether this instance is successful instance, such is successful instance or unsuccessful instance? It is successful case, no? Such is successful. Can you give an example for case where such is not successful?
If the element is not present in the
If the element is not present in the array. For example, same array or key is not present. Key is 54. Then what happens? This is unsuccessful, no? Unsuccessful search or case. Is that okay? Now, how to write algorithm for this? How to write algorithm for this? Algorithm, let us call this as linear search. Name of the algorithm, linear search. What should be given as input? Array should be given. How many elements are there in that array? Whether we take it or not, it doesn't matter. Next, what else should be given? What else should be given? Key should be given as input. What is the first thing that we do? What is the first thing? We are comparing elements from 1 to 1 to 1 to 1 to n. So we take a variable for comparing, okay, no, for index purpose. This I is index. Okay. What is the next thing that we do? We check whether A of I is key or not. A of I is key or not. Okay. A of I is key or not. If it is not equal, if it is equal, are we going to do anything? No, we just come out. If it is not equal, then what is that we need to do?
We continue to compare with the second element.
If it is not equal, again same thing. That means I should go to next element, next position. Next position means what? I equals to I plus 1 we can do. Next position. Again we need to repeat this now. So that's why we can take some loop here now. Which loop is better? I need to repeat. So this is if condition. If this condition is false, again I need to do this. Again we need to check this condition. If it is false, we need to repeat. That means same condition we are repeating multiple times. One time if it is checking and performing some operation means we use if. But the same thing we need to repeat multiple times now. So which operation we perform here? Which operation we perform here? Which loop we use here?
While loop.
To repeat, no. We use some loop, say in this case it is while loop we can use, no? While loop we can use. While A of I not equal to key, we keep doing like this. I equal to I plus 1. But how many times we keep doing like this? For each value of I we do. For what is the maximum value of I for which we do this operation? For example, if n equal to 4, when I becomes 5, still we perform this operation?
No, sir.
No. But that condition we haven't checked, no? That condition we haven't checked. So that means what? Again, there is some mistake here. Again, there is some mistake or not. So what is the mistake? What is the mistake?
Sir, we can write here I less than 4, I less than equal to 4, and A of I not equal to key.
That is important. Okay. Now is it clear? What are the steps we are writing here? I less than or equal to n. I less than or equal to n and A of I not equals to key. Then we are doing this. I equal to I plus 1. Is that correct? Is that correct? What is the next thing that we are doing? What is the next thing that we are doing? we need to do. Okay, we keep repeating this process. When does this condition fail? While loop, when do we come out of while loop? Two
Either
cases we come out now.
yes, yes.
That is, if this fails, I less than or equal to n fails. If it is false, we come out. Even this is false, we come out. If it is false, I less than or equal to n, it is false. What does it mean? What does it mean? That means
Value
here
C
I
will not
value has
exist.
become n plus 1. That is the meaning, no?
Yes.
No. Whether it becomes n plus 2, whether it becomes n plus 2,
No, sir.
no. Because n plus 1 itself, it fails now. If a of I not equal to key, what does it mean? A of I is actually key. A of I is actually key. Is that okay? If A of I equal to key, that means that time what is the value of I? If A of I equal to key, what can I say about value of I in that case? Is
Less
it
than
more
n.
than n or less than n?
Less than
or
n,
equal
sir.
to n. If A of I equal to key, that time value of I is less than or equal to n or more than n.
It's less than equal to n.
If it is less than or equal to n only, we have checked this condition. No, A of I not equal to key. So that means if A of I equal to not equal to key condition failed means A of I equal to key. A of I equal to key means definitely I value is, it implies that I is less than or equal to n. No, is that okay?
Yes,
Now
sir.
based on that, now we have two cases. I is less than or equal to 1 is one case. I equal to n plus 1 is another case. If I equal to n plus 1 means what? Search is successful or unsuccessful?
Unsuccessful.
Unsuccessful. If I is less than or equal to n means search is successful or unsuccessful?
Successful.
Successful. So after coming out of this while loop, we can write simple condition. No? If I is less than or equal to n, then whatever we want, we can write. So that means this is successful case. Okay. Such is successful. Else means what is the value of I? That is I equals to n plus 1. If I equal to n plus 1, what is that we write? Unsuccessful. If it is successful, if we want to, we can even return the position of the element where it is present. No, what is the position in which the element is present? It is the 8th position only. No,
Yes.
it is. All of you are you following?
Yes, sir.
Okay, thank you.
Yes, sir.
Oh, okay. Because sir only responding, others there. That's why I got doubt. Okay, no.
Yes, sir. Following.
Okay, thank you. At least if you are not following, you please ask me question. That way, at least I will understand that you are following. I less than or equal to n, it is successful. Otherwise, it is unsuccessful. Is that okay? Is the algorithm clear? Is there
Yes,
any?
sir.
Yes, sir,
Yes,
it's clear.
yes, yes,
It's okay. Thank you. Now, the same algorithm is shown here. Okay, same algorithm is shown here. Now, what is that we need to do? What is that we need to do? We need to analyze running time of this algorithm. Running time.
Sir, in this algorithm, parameter n is missing, no?
That we can, okay, fine, we can take it as if A is globally declared, no, sir, then it doesn't matter, no? Okay, explicitly, okay, we can even put here n comma key, okay? That is also fine. Even this is because these things are implementation dependent, no, sir? These things are implementation dependent. So a running time of the algorithm. In that case, what is or n? We can write one line. N is length of A. Correct, no, sir?
Yeah, that's fine. Yeah.
One step we can write. That's not a problem. Okay. Now, what is input size here? What is the parameter that indicates input size?
N.
It is n. It is n. Now, what is basic operation? What is basic operation? Now we know that whichever operation is performed more number of times, that operation we consider as basic operation. Now you tell me which operation we need to consider as basic operation. Step number, you please tell me. Step number, which operation it is better to consider as?
3. Step number 3.
Step number 3. Okay, now all other step, only main part of the algorithm is step 3 only. Step 3 and 4. Okay, now step 3 and 4. Now, which operation we need to consider as basic operation?
I less than or equal to n.
I less than or equal to n. Okay. Okay. First, okay, that is also correct what you said. First, let us consider this operation a of I not equal to key. That means this is comparison operation. First, I'll explain with respect to this. After that, I'll come to this. Okay. Comparison operation. This is also in fact comparison only, but I am talking about this comparison now. Let T of n be the, what is T of n? Number of comparisons performed. Number of comparisons performed. Now, what is important thing now we need to decide? Depends only on n, depends on n and the actual values. Actual values in the input. That is input instance. Input instance. Now, out of these two, which one is true? It depends only on n, or it depends on n and the actual values in the input also.
Actual values on the input.
Correct. Now, for example, if we take n equal to 3, if our array is 10, 22, 14, 10 to 14, or key is 10, n equal to 3, what is T of 3? What is T of 3 here? What is T of 3?
1.
1. If key is same thing, our elements are like this, 2, 14, 10. Key equal to 10. How many, what is T of 3 value? It is 3. It is 3. That means what? That means what? If we, even if input size is same, but actual values in the input, they are different, means automatically answer changes, no? Automatically T of n value is different. That means what? It depends only on n or actual values in the input also. T of
Actual
n,
values of
it depends on actual values in the input also. That means it depends on input instance also. Okay. So actually, which is correct? It depends on input instance also. So this is correct. This is correct. Now, if it actually depends on input instance, that means actual value, not only on input size, but also actual values in the input. Then what is the problem? What is the problem that we get? Similar to previous example, no. What is the problem that we get? Even if I tell you that n equal to, because we are in this case, if I tell you n equal to 3, will you be able to clearly tell me what is the number of times a of I not equal to key operation is performed? Even if we know that input size is n, that value is 3, is it possible to say what is the number of times a of I not equal to key is performed?
no, sir.
No. No is correct answer. Why? Depending on the positions of elements in the array, this might change. No, these are counter cases, no, where both are different. Both are different. That means exactly we are not able to say we don't know exactly how many times A of I not equal to key is performed. Here, we do not. Is that correct? We do not know the count of A of I not equal to key. Is that correct? Then okay, exact count of the exact count. Then what is that we need to do? Exactly, we are not able to say how many times A of I not equal to key. That comparison operation is performed. Comparison operation is performed. That means what is this exact count of basic operation? Basic operation. So in that case, what are the options we have?
We can probably tell the minimum number and maximum number.
We can say it is repeated at least this many times. At least. That is minimum number of times. Minimum number of times it is performed when n is input size. We can say maximum number of times. Maximum number of times it is performed. At least we can say that, no? That means where n is input size, if n is input size, what is the minimum number of times basic operation is performed? N is input size, what is the minimum number of times basic operation is performed? That values we can calculate now. Then that means what? If any input size whose value is n is given, any input whose size is n is given, then we can easily say T of n is greater than or equal to this much. Is that correct? That is when in this case. Is that correct? Is that correct?
Yes, sir, correct.
So in the second case, what is that we can say? Any input whose size is n is given, we can say that number of operations performed in that is not more than this. That much we can say, no? That much we can say.
Yes.
sir.
Okay. Then this is actually called the best case running time of that algorithm. This is called best case running time. That means what? For any input instance whose size is n, okay, no, is n, the number of operations performed will be at least that much. Definitely not less for any instance of size n. Similarly, this is actually worst case. That means for any input of size n, total number of times this operation is performed is not more than the value, this value. Now, can you please tell me what is the comparison operation count when in the best case? In the best case, what is T of n in the best case?
1, sir. 1.
That is, when does that best case occur?
When we search
First
for
element.
10.
That no, not like that.
When the key exists at the first position.
That is,
Yes,
when
sir.
key is present in first position, always it is best case or not?
Yes, sir.
Okay, that are you getting?
Yes, sir.
Okay. Now we know that this operation exactly we are not able to count how many times it is performed, but we can clearly say what is the minimum number of times that is performed. So that we call it as best case running time. Similarly, what is the maximum number of times that operation is performed? Corresponding time we call it as worst case running time of that algorithm. Is that okay? So anyhow, other steps we are not interested in. We are not even calculating what is the amount of work done, all these steps. Are we calculating? Is it what the calculating? Is it necessary? Is it necessary? Is it necessary?
No.
Is it necessary? Is it necessary or not?
No, sir, it's not necessary.
because when we are going for minimum and maximum calculation, okay, when we go for minimum calculation, other steps, the amount of work we do may be sometimes more. That's why it is better to calculate what is the amount of work done in other steps also. All these are anyhow constant amount of work, only one time, no? Only one time it is performed. Here also it is either 1 or 0. This is 1 or 0. This is 0 or 1 time it is performed, no? If it is fifth step is 1 time means sixth step it is 0 times. Fifth step is, okay, it is always 1 time, no? Whether it is true or false, that operation should be performed, no? Sixth step, if it is false, then only it is performed, 0 or 1 time. Then what is, this is performed only 1 time. Okay, no, this is performed, this is only brace, no? So what is total number of times it is performed? 1 plus 1, 2. This also, if we can take at max as 1, 3, and this is 1. So total, other than this, what is the amount of work we are doing? 3 operations, no? 3 operations. Is that correct? Is that correct? Is that correct or not? Is there any
Yes,
doubt in this? Even if you don't calculate also, no problem, but still what I'm saying, no, sometimes what happens is when we go for best case, amount of work, other steps, it may be more. Okay, that purpose I explained here. Okay, that purpose I explained here. Okay, now we are not even considering what is the work done in other steps. Okay, let us say now what. Okay, let us see. Let me take a new slide. Now, is it clear whatever we discussed so far? Whatever we discussed so far, all of you please read this. Is there any doubt? Is there any doubt?
No, sir.
no, sir.
Okay, okay. It is summarizing whatever we discussed. That's now next. So what is running time of an algorithm? What is running time of an algorithm? It is total number of operations performed in our algorithm, no? Or operation count. Operation count. Now, in these cases where number of times a particular operation is performed, it not only depends on n, but also actual values in the input. We will get different cases. The cases, 3 cases actually we consider are best case, worst case, and average case. Okay, no, best case, worst case, or so that we call it a T best of n, best case running time, or T B of n. Okay, no, or T best case, whatever it may be, best case running time of n. When n is input size. Similarly, this we call it a T worst case or TW of n. So what is best case running time? What is best case running time?
The minimum number of steps performed
That is
to
when
complete the
n is
task.
input size. For any input whose size is n, what is the minimum number of times that operation is performed? What is worst case running time? For any input of size n, what is the maximum number of times that given operation is performed? Okay, that is basic operation is performed. Okay, what is average case running time? What is average case running time? On average, what is the number of times that basic operation is performed when n is input size? But average case running time, we actually need to consider about distribution of input, all those things that we'll discuss after some time. Okay, after some time. Now, just last minute, I stop. What is, now tell me what is best case running time of this linear search? What is TB of n? What is TB of n? In the best case, how many times that basic operation is performed?
1 time.
Once.
1 time. Is this correct? What is worst case running time of this linear search?
N times.
N
N
times.
plus 1.
It is n times. whatever operation we consider a of I not equal to k, a of I not equal to key, it is performed only n times, no? Worst case, for each key it
Yes,
checks.
sir.
That's all, no? For each value it checks. So it is n. It is n. Is that okay? Now, what can you say about average value? Whether is it definitely greater than or equal to TB of n or not? On average, what is the number of times that operation is performed? Whether it can be less than number of times it is performed in best case?
No,
It will be more than best case.
Definitely, it
more
is
than
minimum
best case.
minimum
More than or
any
equal to,
input
yeah.
of size n. So definitely it should be true. Similarly, TA of n and TW of n, what is the relation? Definitely TA of n should be not more than TW of n. Worst case
Yes.
time count. Worst case
Yeah.
number of times it is performed. So therefore, what is TB of n less than or equal to TA of n less than or equal to TW of n? Is this correct? Always?
Yes, yes, sir.
Okay, it's correct, no? It is correct.
Yes, sir.
Okay. Okay, so therefore, finally, we have got answer for this. What is best worst case running time? It is n. It is n. What is its order of growth? What is its order of growth? What is order of growth?
T of n.
Order of growth of n is n only, no?
Yeah.
Yes.
Okay, W anyhow I put heading worst case running time. No, what is order of growth of T of n? Worst case means I am talking about only this is worst case. What is order of growth of T of n? It is n only. It is n. Now can we represent it as T of n as theta of n?
N.
Is that correct? Is that correct?
Yes, sir.
Okay. Here best case T of n is 1. What is order of growth of T of n? 1 means it is n power 0. N power 0, order of growth of T of n is n power 0. So that means what? T of n can be represented as theta of n power 0, that is theta of 1. Is that correct?
Yes, sir.
Yes, sir.
Okay. Okay. Oh, we will have break for some 25 minutes. That is 6:30. Again, we'll assemble. Okay.